Alright, Bismillahirrahmanirrahim. Assalamu alaikum students. Let's start with a very important topic as far as our uh, reasoning concepts of statics is concerned. Okay, and this topic is redundant constraints and improper constraints. Okay, so whenever a body has redundant supports, that is more supports than are necessary to hold it in equilibrium position, it is called as a statically indeterminate case. It is called as statically indeterminate. What does it mean by more support? For example, if you look at this cantilevered beam, okay, which is being fixed from one side, and there are basically two rollers over here, okay. So if you look, it has basically a fixed support will give you three reactions, okay, and those three reactions will be AX, AY, and MA. But along with, they have also provided you with two more reactions, BY over here and CY. So the total number of reactions now the body has is basically 3 plus 4 plus 1, 5. Okay, so basically 5 reactions because of the supports, and you know the equations of equilibrium. Under this scenario, you have basically 3 equations of equilibrium. So this will make it a statically indeterminate case. Okay, you cannot solve this kind of a scenario. It is a statically indeterminate. In statics, you cannot solve it. Okay, so statically indeterminate means that you have that there will be more unknown loadings, okay, on the body than the equations of equilibrium available for their solutions. Okay, so you can very easily say that in this scenario over here, if you look at it, here you have basically, here you have three unknowns, here you have three unknowns, and you have got one unknown here, and you have got one unknown here. So altogether you have, if you look at it, you have five unknowns. Okay, and you know equations of equilibrium you have here is 3. Okay, so 5 unknowns and 3 equations of equilibrium is not solvable. So you will always call this kind of a case as basically it is statically indeterminate. Okay, so that there will be more unknown loadings on the body than the equations of equilibrium available for their solution. Okay, like in this scenario. In the same way, if you look and come over here in a three-dimensional scenario, okay, if you look at a three-dimensional scenario, this pipe, if you look at it, is basically being fixed supported over here. Okay, if you look, it is being basically fixed supported over here. Okay, and since it is fixed supported, it is fixed support. It is fixed supported, and basically in 3 dimensions. So you know in 3 dimensions, you have already studied it, you will have how many unknowns? You will have 6 unknowns. You will have 6 unknowns, and you can count it 1, 2, 3, 4, 5, 6, and at this they have basically here you can see this is a pin support. Okay, this is a pin support. Okay, and this pin support basically they are taking as 2 unknowns. Okay, 1 and 2. So basically 6 and plus 2 is basically 8 unknowns, and since they have 8 unknowns, so to all together how much? You will say 8 unknowns. Okay, 6 plus 2, and in 3D we have already discussed, in 3D you have 6 equations of equilibrium. So again this is a case of a statically indeterminate pipe. This is a statically indeterminate pipe, and it cannot be solved through our conventional static techniques. So we will call this pipe 3D scenario as a statically indeterminate pipe system, and since there are more support reactions than the equations of equilibrium, so this will be called as that it has been a redundant pipe system. Okay, So when the system is over constrained, it is called as a as a as a redundant constraint system, or it is over constrained under the heading of redundant constraints. There will be some systems which is which can be under constraint, which means you have less number of supports and more equations of equilibrium. Still, it will be a redundant uh, under study under redundant constraint. It will be under constraint. Okay, so that's just for extra knowledge I am trying to tell you. So now we go to improper constraints. Okay, so improper constraints is that sometimes we should not take it easy that if we have the same number of basically reactive forces, which means the number of supports are equal to the number of equations of equilibrium. Okay, which means that the scenario is, which we will take it very easy, that number of unknowns is equals to equations of equilibrium. Okay, so he says that the same number of relative forces same number of reactive forces are available equations as available equations of equilibrium does not always guarantee that the body will be stable when subjected to a particular loading. Okay, so if you look at it for this pin support, if you look at this over here, if you look at this pin support over here of this beam over here. Okay, so if you look at this beam, there is a pin over here and there is a roller over here. Okay, so if you look at it, this this pin and this roller. Okay, if you say there will be two unknowns here and see the two unknowns here, and there is one unknown over here. Okay, so what does he say? The pin support at A and the roller support at B for the beam are placed in such a way that the line of action of the reactive forces are concurrent at point A. You can see that the line of action of AX and AY are concurrent, and not only that, the line of action of this roller through the concept of principle of transmissibility is also concurrent at this point. Okay, because you know force is a sliding vector. So all these three are concurrent at this point A. So consequently, this applied loading P, if you look at it, this applied loading P, since the roller is placed here and roller can translate in the positive Y and negative Y, this P, if you look at it, this P's vertical component, its vertical component has the tendency to rotate this piece. If you look at it, it will have two components. This component of P, the vertical component, has the tendency to rotate this component basically can create a rotation, okay, from A. Okay, so it can create a rotation from the point A. So the beam is basically improperly constrained. Okay, and you can, since there is a rotation, so you can easily say that summation of all the moments at A is not going to be equal to 0. Okay, so you will say summation of all the moments at A is not equal to 0. Okay, and another case is over here for us. We are because this is a 2D scenario, and for example, in 3 dimensions, a body will be improperly constrained if the line of action of all the reactive forces intersects a common axis. Okay, so if you look at this 3D scenario, the line of action of all the reactive forces. Here they have given you a ball and socket, and here they have also given you a ball and socket. Ball and socket in 3D has 3 reactive forces. Over here 3 reactive forces. Okay, so altogether there are 6 reactive forces. Okay, but they are all intersecting at a common axis. And what is our common axis? If you look at it, this is the common axis. If you look, this is the common axis. Okay, this is the common axis. They are intersecting at this common axis. Okay, so when this is the scenario, okay, reactive forces support. Okay, so for this scenario, these reactive forces in the ball and socket supports at A and B. Okay, so all since they intersect through this axis passing through A and B. Okay, so since the movement of these forces about A and B are all zero, okay, because all these forces are passing about this axis, so there the movement will all ma summation of movements about A over here and summation of movement about B. Okay, it will be zero. Okay, as there will be no movement arm. Okay, so they all intersect axis passing through A and B. Okay, and since the movement of these forces about A are all zero, okay, then you can already say that this force P, okay, this force P has the tendency, this force P will have the tendency to rotate this this piping system. If you can induce, if it's a pipe, it can reduce and rotate about this scenario. Okay, it can rotate about this AB axis. It can rotate about this AB axis. This AB axis, remember, is basically in the minus x and y plane. Okay, so it has the tendency to rotate about this axis, and since it will be able to rotate about this AB axis, okay, so it means that for summation of all the moments about A and B will not be equal to 0. Okay, this is a very important, the summation of this tells us that it will not be equal to 0. So one of the scenarios is this, and he says that reactive forces at the ball and socket supports an A and B all intersects the axis passing through. They can see this and this, they are all intersecting the axis passing through A and B. Okay, and the moment of these forces, since they are intersecting, as no momentum there about an A and B, are all 0, because see, there will be no momentum, they are passing through this axis. So we can say that this force P, the load which we applied, will create a rotation, basically a moment, and that is why we say that summation of moments of A and B is not equal to 0. Okay, then you have another force, another thing, another way in which improper constraining leads to instability occurs when the reactive forces are all parallel. Okay, when they, for example, in this system, in this 3AD scenario, okay, they have got x, y and z, and this is being all fixed at the roof or any horizontal plate. Okay, so you can see that this is fixed along y, these are all three parallel forces. Okay, they will create basically instability. Okay, and you know that there is a horizontal force along the x-axis. Okay, and you can basically very easily apply sigma fy, but you cannot apply sigma fx. Okay, sigma fx will not be equal to 0. So this 100 Newton force along axis would create a rigid body rotation in this 3D piping system. Okay, another, this is a 3D scenario. You can also have a 2D scenario. If you look at it, there are two rollers placed over here. There are two rollers placed over here, and this force P. Okay, we can assume that it is assume making an angle of alpha. It will have two vertical components, a horizontal component, and it will have also have a vertical components. Okay, we can say it can have two components. Okay, okay, it can have these two components, and you can say these two components. Okay, and if you look at it, this will be the horizontal component and this will be the vertical component. This horizontal component, if you look at it, okay, you can easily apply sigma fy over here. Okay, fa plus fb, and assume angle is alpha, p sine alpha. Sigma fy is, but what we will do when you apply sigma fx? When you apply sigma fx, it will not be equal to sigma fx equal to 0, but when you apply this p cos alpha will not be equal to 0. It will create, see, this is a roller over here, there is a roller here and there is a roller here. This force P will tend to create a translation along the x-axis. So the body will not be in static equilibrium. It will create translation. Okay, so now this has been understood by us. Let's go to another. In some cases, the body may have a few reactive forces. Reactive forces. For example, it will be still basically it will be having lesser supports than the equation of equilibrium that must be specified. The body then becomes only partially constrained. Okay, it will only become partially constrained. Okay, so if you look at this member AB, just this member AB. Okay, if you look at this member AB and draw its free body diagram, okay, sigma Fy equal to 0 will not be satisfied. Okay, you can say this free body diagram is sigma, this is Fa, this is Fb, Fa and Fb. You can basically satisfy sigma Fx equal to 0, Fa equals to Fb, equilibrium satisfied. But now you apply sigma Fy equal to 0, so it cannot be satisfied. So because 100 is not equal to 0. Okay, and if you assume this distance say s, okay, from 100, and you apply summation of moments at equal to 0, so 100 into s, what we have assumed, is not going to be equal to 0. Okay, because 100s is not equal to 0. So it is basically constrained along the x, but it is not constrained along the y, and basically you could also not apply summation of moments about a also equal to 0. Summation of moments cannot be applied, so only partially constrained. So these type of scenarios in which the body uh, is partially constrained, okay, you have fewer reactive forces than the equations of equilibrium. Okay, then the body becomes partially constrained, so it will not be in equilibrium. Okay, and thus the equilibrium will not be satisfied. So just to summarize our results, a supported object is said to be statically indeterminate in two circumstances. Because of the redundant supports, the object has more supports than the minimum number necessary to maintain equilibrium. That scenario is called over constraint. Very important, the difference between the number of reactions due to support and the number of independent equilibrium equations is called degree of redundancy. So very important point, it is called as the degree of redundancy. The number of reactions due to the supports and the number of independent equilibrium equations. Okay, so what does it mean? It means that if you have uh, the difference between number of reactions due to the supports, okay, if you have for example 6, if you have so if you have 6 reactions because of the supports, okay, okay, if you have 6 reactions, and or you can assume, you can also say, if you have, for example, you can say you have 8 reactions, okay, and in 3D, and you have 6 equation of equilibrium. Okay, so under this scenario the degree of redundancy will be 2. Okay, since 8 minus 6 will be equal to 2. Okay, that difference between the number of reactions due to the supports and the number of independent equilibrium equations is called degree of redundancy. Okay, 8 minus 6 is 2. Another very important that I have already discussed with you is a body can be under constraint. Object has less supports than the minimum number to maintain equilibrium. Okay, for example, here basically your, if you look at it, how many supports you have, basically support reactions, you have basically 2 reactions, you have 2 reactions. Okay, and how many equations of equilibrium you have, how many equations of equilibrium you have 3. Okay, so again if you look at it, you can say that the difference is basically again a difference of 1. The statical degree of redundancy will be a difference will be 1. So again it is also called as a statically indeterminate case, it cannot be solved. Okay, then you go for improper supports. The supports cannot maintain the object in equilibrium under the loads acting on it. Okay, so this is a summary, and I hope I have tried my level best. It's to understand this topic of redundant supports and improper supports. It's also called as redundant constraints and improper constraints. And uh, I would like to thank you all, and inshallah I will come up with a new video very soon. Thank you very much.